All right, we are up to lesson 11 now, so let's go to our examples. Here's a clock showing an hour hand at 3 p.m. Your teacher will give you a time. Identify the radian angle measure that the hour hand rotates through if it starts at 3 p.m. So, a couple things before we start. Okay. We know that if this is a circle, we know that directly right of center is 0 degrees. Okay, we know directly up is 90. This is 180. This is 270 degrees, so on and so forth. In radians, this would be, remember, pi over 2. This would be pi. This would be 3 pi over 2, so on and so forth. So at 3 p.m., the hour hand is obviously pointed towards the 3. So I'm just going to make up some examples here because it says your teacher will give you a time. So for our first example, we are going to do 7 o'clock p.m. So at 7 o'clock p.m., okay, the hour hand is obviously going to be pointed towards the 7, and what we want to figure out is how much is this angle right here. So let's take a look. Let's go back to our notes from lesson 1. Okay. So first of all, what I want to call your attention to is this right here. Okay. We already know, we've already talked about this ad nauseum, that when we rotate in a counterclockwise direction, that is a positive rotation. But we, of course, know that we can also rotate clockwise. So if we rotate clockwise like we do on a clock, the angle is going to be negative. So when you count the number of degrees or the number of radians, that something rotates in a clockwise direction, the rotation is going to be negative, whether it be degrees or radians. So that's really important. The next thing we want to figure out is on the clock, how many degrees or how many radians is each spot worth? So when I move one number on the clock, how many degrees or how many radians am I moving? So I'm going to do that off to the side right here. So I'm going to do that off to the side right here. So I know that there are 12 numbers on a clock, okay? I also know that going around the clock one full time is 2 pi radians, right? Or 360 degrees. Okay. So I know that going around one full rotation is 2 pi radians. I also know that there are 12 spots on the clock. So that means each spot, if I divide that, 2 pi over 12 is going to be equal to pi over 6. So each time I move a spot on the clock, I'm moving pi over 6 radians. So when I go from 3 p.m. to 7 p.m., I'm moving 1, 2, 3, 4 spots. So I'm moving 4 spots. Each spot is worth pi over 6 radians. So that's going to be a total. So when I multiply that out, that's going to give me 4 pi over 6. And if I reduce that, I can divide both of these. I can divide numerator and denominator by 2. I can make that 2 pi over 3. However, the answer is going to be negative 2 pi over 3. The answer is not going to be 2 pi over 3. The answer is going to be negative 2 pi over 3 because I rotated clockwise. I moved clockwise on the clock. So the answer at 7 p.m., from 3 p.m. to 7 p.m., the hour hand has rotated negative 2 pi over 3 radians. Okay? Let's do a couple others. Let's do, for our second one, we'll do 1 o'clock. Okay? We're going to do 1 o'clock a.m. Okay? We're going to do 1 o'clock a.m. So let me do another arrow here. So at 1 o'clock a.m., it's going to be pointed up towards the 1, obviously. So if I start at 3 p.m. again, and let me erase this. If I start at 3 p.m. again, it's going to be moving 4 p.m., 5, 6, 7, 8, 9, 10, 11, 12 a.m., and then 1 a.m. So that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 spots. So between 3 p.m. and 1 a.m., it's moving 10 spots. And we already established that each spot is worth pi over 6 radians. Okay. Pi over 6 radians. So when I multiply that out, that's going to be 10 pi over 6. So if I reduce that, again, I can divide numerator and denominator by 2. That's going to be 5 pi over 3. But my official answer is going to be negative, again, because I am rotating in the clockwise direction. So between 3 p.m. and 1 a.m., the hour hand is rotating negative 5 pi over 3 radians. Okay. Let's do another one now. Okay. Let's do 6 a.m. So between 3 p.m. and 6 a.m. Okay. So this one is interesting because I'm going from 3 p.m. to 6 a.m. So we obviously know at 6 a.m. the hour hand is pointing directly downward, but it's not moving 3 spots. From 3 p.m. to 6 p.m., it's moving 3 spots. But from 3 p.m. to 6 a.m., it's going all the way around the clock once and then 3 spots. Because this is going to be 4, 5, 6, 7, 8, 9, 10, 11 p.m., 12 a.m., 1 a.m., 2 a.m., so on and so forth, down to 6 a.m. So it's really moving 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So between 3 p.m. and 6 a.m., it's really moving 15 spots. Okay. Each spot is worth pi over 6 radians. So when I put that together, that's going to be 15 pi over 6. Okay. In this case, I can divide both numerator and denominator by 3, because 15 divided by 3 is 5, right? So that'll be 5 pi. And 6 divided by 3 is 2. So that reduces to 5 pi over 2. But remember, the final answer has to be negative. So the point of this activity is twofold. Okay, it's to show that when we rotate on a clock, that each spot is worth pi over 6 radians, okay, because I know that one full revolution is 2 pi radians, and I know that there are 12 spots, 12 numbers on a clock, so that gives me each spot as pi over 6 radians. So to figure out how much it rotates, I have to count the number of spots and multiply it by pi over 6. So I did 3 p.m. to 7 p.m., I did 3 p.m. to 1 a.m., and I did 3 p.m. to 6 a.m. And I did that again by counting the number of spots it moves on the clock and multiplying it by pi over 6. And then when I was done, I had to realize that because it's a clock, because it's rotating in a clockwise direction, that the final answer is actually negative. When we are rotating clockwise, the angle is negative. When we're rotating counterclockwise, like we normally do, the angle is positive. And that is it for this lesson.